Good afternoon. Today we are going to continue on with those algebraic expressions, and this time we are evaluating them. What does it mean when we evaluate, Finley?
Solve.
To solve. You do the math. So the last one we were just writing out what the expression looked like, writing out the verbal phrase. Now we're going to be doing the math. So our progression from expressions to equations continues. First we wrote expressions, then we simplified them, and now we are going to evaluate them with given values for the variables. So when we have those letters, we will also represent the expressions graphically. So you've had experience figuring out what that value is, how to put the value in for the letter, and how to solve it. Graphing it is a little bit different. So we're adding on something new to something you already know. Remember the order of operations. It matters. Also be careful when the value of a variable is negative, particularly when squaring. This sign is important and must be included. So when we say something like that, if we have -2 squared, what does that mean? What are we doing? Henry?
That's -2 times
-2 times -2. What's a negative times a negative,
Positive.
Elliot?
Positive.
Positive. So your answer would be a positive 4. So really think through when you're squaring, when you're cubing with those negative numbers, what it means that you're doing. Is your answer going to be positive or is it going to be negative? So really have to pay attention to that. So in this first section, we are going to rewrite each expression when a equals 9, n equals 20, x equals -5. Then you're going to evaluate it. You're going to do the math. So the first thing we do, no mental math, no gold stars for mental math. You're actually rewriting the expression with that variable value in it. So if we have 12 times a, because we know if we don't see the operation right next to it, it means multiply. So 12 times a is 9, minus n is 20. So we're going to write that expression out with the correct numbers in it. Now it's our order of operations objective that we did. First thing I'm going to do is multiply before I subtract. So 12 times 9 is 108 minus 20. 108 minus 20 is 88. So some of us, my friends, did not write out each step when we had our last test and we got it wrong. Remember, I am not making you write the steps just to be mean, to give you extra work. We need to get in the habit of doing all the steps. I know what's coming in the future. Don't fight me on this. Don't say, oh, I can do it mental math. Oh, I can do it my way. I can multiply this on one side and subtract that somewhere else and then figure out my answer. That is not going to help you in the spring. I'm showing you the steps to do. Do the steps. Get in the habit now when it's easier math. So when it becomes harder math, it comes easy for you. Finley.
Can we use our calculators to check our answers?
Yes. All right, so if we have a plus x plus 2, so I'm going to put 9 in for a, -5 in for x. I put a little parentheses around it because it doesn't look right if you say 9 plus minus 5, right? That looks goofy. So I put parentheses around when it's a negative number. So I remember, oh, it's a -5. And then plus 2. So our first thing we're going to do is that 9 plus -5. So remember on that number line, what are we actually doing? Henry?
We're going backwards.
You're subtracting. When you add a negative, you're subtracting on that number line. If you need a refresher, flip back to that objective, because we did this on our last unit. So 9 plus a negative 5 would be a 4. Bring down the rest of my expression. 4 plus 2 is 6. So work through doing that PERMDAS. Remember how we do our steps to figure it out. They do get more complicated as you go. So go slow. Make sure you're doing the correct steps in PERMDAS. So our next section says write each situation as an expression, evaluate it for the given values, and then graph it. Woo. Let's see what that means. We haven't graphed an expression before. So let's say you want to buy an iPhone and decide to put $3 each day into savings. How much will you have saved on day 5? How about day 8? How about day 12? So something is going to be a constant, something that you're always doing. And then you're going to have your variable that's going to be changing. So what is it that is changing every time? Joe?
The amount of days.
The amount of days. So our days is what's changing, right? So we're gonna put in a variable of D for days, because that's what's changing every time. Now we need to come up with an expression. Our days are changing. What is it that's staying the same every day? What, Elliot?
The amount of money that you put in savings.
Yeah, so the amount of money stays the same. So we have that $3 every day. So what would my expression look like to figure out if it's day 5, if it's day 8, if it's day 12? Colton?
3 times D.
Yeah, 3 times D. So that is my expression, because I figured out what it was changing for my variable, and then you always have to figure out, am I multiplying, dividing, adding, or subtracting that constant that's always there. So if we're putting aside $3 every day, we know we're multiplying it by 3. So now we have to put in day 5, day 8, and day 12 into our equation. So on day 5, I'm going to use my equation. 3 times what?
5.
Times 5, because it's day 5. 3 times 5 equals what? $15. So my next one is day 8. So I do 3 times 8. What is 3 times 8? Finley? $24. And then I have day 12. So 3 times 12 equals what? Avery?
36.
$36. So I know how much money I'm going to have in my savings on those 3 different days. So now I need to graph it. So when we graph it, we're going to put our days as our X axis, and then our savings we're going to put as the Y. So the days is what we're changing every time. Our savings is what we're going to get out of it. So day 1, because we know where the 2 cross, that's 0. Day 1, day 2, 3, 4. How far up do you think I want to label, Elliot? out to 12 days. Sometimes we might not have enough room on one of our axes, so we might have to skip count. But we have enough room for the 12 here. Now we're going to go up. How far up do I need to go? Emily? 36, because we have $36 in savings. Oh goodness, I don't think I have 36 lines. So what do you think I should skip count by? Ellen? 2. Okay, I could skip by 2s. There might be a better choice of what to skip by. What do you think, Grayson?
4.
I could skip by 4s, but there's a better choice. Looking at my expression, what might I want to skip by, Grace?
3.
3s, because I know it's going up by 3s every time. Then I don't have to deal with the halfway marks. Because I know all of my answers are a multiple of 3. So I'm going to skip by 3s here. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. I don't have to go any farther because the highest number I have is $36. Now I'm going to graph it. On day 5, so I come to day 5, I have $15. On day 8, I come over to 8, I have $24. And on day 12, I have $36. So that is my graph of that expression. So when you graph the expression, it's important that we label our axes. We have our days. So what is that variable that's changing? That's the x. What you get out of it is the y. Okay. I'm going to erase this so we can look at our next page. Your parents give you and your sister points for each chore completed, and today, in the spirit of Christmas, they are going to double the total points earned. Before doubling, your sister earned 7 points. How many total points will the two of you have if you earn 3 points, again, before doubling? How about 10 points? How about 15 points? So, what do you think that expression is going to look like? First thing we want to decide is what's our variable that's going to be changing? What are we changing each time? Well, points. So I know my variable is going to be the points. Okay, that's changing. So I know in my expression I'm going to have a p because my points change every time. What else do I know about, what other information do I have? Joe?
You have 3, you put on 3 points, 10 points.
Yeah, we're going to be putting in those different point values for our variable of p. So we know the points are going to be changing. So if we know the variable, now we have to look at what's constant, what's going to always be there. Elliot?
The people who are like, it's you and your sister.
Yep. So we know the people earning the points are you and your sister. That doesn't go into the expression, we just know that. Gavin?
Doubling.
We're going to be doubling. What does it mean to double? Ellen?
Times it by 2.
We're going to be timesing by 2. What else do we know? Finley?
How many points take 4?
Which is what?
7.
Yeah, because your sister earned 7 points before the doubling starts. So you already have 7 points in that bank. how am I going to show that in my expression? You've got 7 points, and then you earn 3, you earn 10, you earn 15. Got a guess, Joe?
Yeah, 15 plus 7 in parentheses.
So are we gonna put 15? Because remember, our expression has the variable.
7 plus p, in parentheses, multiplied by,
Yes, because we know there was already 7 there, then we add on our new points. So we add all the points together, what we already had and what we have now earned. So that's why it's in parentheses, and then we're gonna double it. So that is our expression, 2 times parentheses p plus 7. So you have to break it down. What's your variable, the thing that's changing each time? What's your constants? What numbers are gonna go into that variable? So you had to figure out that doubling means we're multiplying by 2, but we had to have that total number of points, so we have to add that 7. Henry, you wanted to say something? Okay. So now we need to figure out how to graph it. So we're going to put in those different variable values. So, how many total points will the two of you have if you earn 3 points? So we have 2 times 3 plus 7 equals what? Cam?
20.
20. Because 3 plus 7 is 10, times 2 is 20. Now we're going to put in 10 points. 2 times 10 plus 7 equals what? Joe?
34.
34. Because we have 10 plus 7 is 17, times 2 is 34. What am I going to put for my next expression? Elliot?
15.
So I'm going to put a 15 in there. So 2 times 15 plus 7. So 15 plus 7 is 22. Times 2 is what, Gavin?
44.
44. Oops. I said 44, but I wrote the wrong number. 44. Now I need to figure out how to graph it. Who remembers what I said that x-axis is? What do we always put as the x-axis?
Variable.
The variable. So what's our variable that's changing? Ellen?
Points.
Points. So labeling your graphs is important. We need to know what those numbers are. Labels matter. So our variable is points. That's our x-axis. What are we getting out of the expression? What are we finding? What's my y-axis? Ellen?
Total.
Total what?
Points.
Total points. So my y-axis is the total points, what we're getting out of it. Now we graph it. So what am I going to graph for my first expression? Joe? Oh wait, no, first we have to number. My bad. We labeled it, now we need to put our numbers on. So down below, I need to go up to 15. So I think I have 15 lines down here, so I can label it by ones. Total points, I need to go all the way up to 44. Ooh, that's going to be too much. What do you think I should skip by? Finley?
2.
Yeah, I think skipping by 2. I think looks like I might have 22. Let's check and see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Uh-oh. I'm at 22, which is only halfway, but I'm more than halfway up. Well, let's see, I might have to add a little lines. 30, 32, 34, 36, 38, 40, 42, 44. So I'm just going to add to my graph. And that's okay if you have to add to your graph a little bit. Or you could have gone back and switched it and skip counted by 4s. But if you add to the top, if you're just short a couple, it's okay. Now I have to graph it. So what am I going to graph first? Henry.
You're gonna go to 3, because you start with 3 points.
Mm-hmm.
And then, since we know we already have 7, like 10 times.
So I've already done the math.
You just do 3 and then 20.
Yeah. You do what your variable changed, that's your x. What you get out of it, what it equals, is your y. So 3 up to the 20. So what's my coordinates I'm going to graph next? Finley. Oh, I thought you were raising your hand. Who can look at that? What coordinates am I going to graph? Remember, our coordinates are the x and the y. X is our variable. Y is the answer, right? What you're getting out of it, out of your expression. So what's my variable for my second expression, Bo?
10.
10. What do we get out of it?
34.
34. So my variable for that second expression is 10, 34. So I need to graph that. 10, and then go up to the 34. And our last one, what is my coordinates? Laura? 15 and 44. So you got to take it one step at a time. Figure out your variable, figure out those constants and how it's increasing or decreasing. Am I adding or subtracting? Am I multiplying or dividing? So write your expression out, then you plug those variable values into your expression.
Please excuse the interruption. Alyssa Ketchmark, can you come to the office for a message? Alyssa Ketchmark.
So then you're going to graph those ordered pairs. The ordered pairs are the variable and the answer. I'm going to erase this so I can scroll up. Our next question. You are starting to train for a marathon. You can already run 3 miles, and beginning on day 1 of the program, tomorrow, you'll begin to increase the distance you run by 1/4 of a mile each day. How far will you run on day 4? How about day 8? How about day 64? So you're going to figure out what's your variable, what is it that you're changing every time, how are you changing it, multiplying, dividing, adding, subtracting, and then put in those variables to find the answers, and then you're going to graph it. Let me look at something real quick. So really, we did the first page together, we did the top one together, so your homework is figuring this bottom one out. Really try to figure it out yourself. Don't ask your friend, oh, what did you put? What's the variable? What's the expression? Try to figure it out yourself. Really try to work it through. If you finish before class time is done, you are working on Khan Academy, working on packet number 2, working on your Mysteries of the Rosary, checking in with me to see if you have any practice works and retakes for tomorrow, because tomorrow's a retake day. So let's work quietly on this last problem. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day. Don't forget to like and subscribe.